Since their introduction in 1986, the award-winning Ford Taurus and Mercury Sable have seen a steady stream of improvements made in response to the ever-growing needs of our customers. And they have responded by making the Taurus America's best-selling car. For the first time, Ford Motor Company introduces an all-new Taurus and Sable for 1996. During this program, we'll look at the new features that are sure to bring customer satisfaction to a new level. The body, chassis, electrical, and powertrain service features presented here should enable you to ensure your customers that you'll fix their concerns right the first time, on time. Four different engines are available for the 1996 Ford Taurus and Mercury Sable. During this program, we'll look at vehicles equipped with the 3-liter Vulcan 2-valve and the 3-liter Duratec 4-valve engines. The 3-liter flexible-fueled engine, as well as the 3.4-liter Taurus show engine, will be covered in a separate program early in 1996. All powertrains use EEC5 powertrain controls with a 104-pin PCM. Engine performance diagnosis and service are similar to other OBD2 EEC5 vehicles using the 16-pin data link connector. If necessary, speak to your service manager about attending FCSD technical training for EEC5. The 3-liter Duratec is similar to the 2.5-liter engine used on Contour and Mystique. It's a V6 with dual overhead camshafts, 4 valves per cylinder, and a peak horsepower of 192 at 5,700 RPM. The single belt accessory drive includes 6 pulleys. The power steering pump and water pump are both mounted directly to the aluminum front cover, and the AC compressor uses a bracket which is bolted to the engine block with non-replaceable torque-to-yield bolts. The bracket is also attached to the engine front cover using 2 dowels. These dowels are critical. The compressor bracket serves as a mounting point for the front engine mounts. Also, be aware of the crankshaft pulley. The bolt has a left-hand thread, so it must be loosened in a clockwise direction. The Duratec engine uses aluminum components throughout, including the cylinder heads and cylinder block. This means that you must take special precautions to avoid damaging any engine parts. Clean all gasket surfaces with a plastic or wood scraper and the appropriate solvent. Do not use metal gasket scrapers. Always follow the specific torque and detorque sequences shown in Section 3-1B of the service manual. And also, follow the specific sequences for removing, installing, and tightening the camshaft bearing caps. To avoid damage, thrust caps must be removed first and installed last. Use the thrust cap as a guide to align the camshaft before tightening the other caps. Like the Contour and Mystique Duratec engine, special procedures are required to set timing. The 2 timing chain tensioners must be bled, compressed, and locked for installation. Aligning the arrows on the backs of the camshafts places the number 1 cylinder on the compression stroke. As with all service procedures, follow the steps in the service manual very carefully, and remember that the engine front cover can only be serviced with the engine removed from the vehicle and placed on a suitable engine stand. The 3-liter Duratec's upper and lower intake manifolds are both aluminum. A cable is used to open the secondary intake ports. A return spring closes the ports. Don't loosen the retainer bracket bolts. This may distort the alignment and severely reduce cable life. An electric intake manifold runner control motor actuates the system under the control of the PCM. The PCM also controls the electronic ignition system, energizing the ignition coil based on a signal from the crankshaft position sensor. The 3-liter Duratec uses a closed cooling system with a ratcheting pressure relief cap. As with all other pressurized systems, don't remove the cap on a hot engine. The cooling system also uses a new thermostat with a 2-piece housing. It's located near the reverse-mounted offset starter motor, which operates in a reverse direction. Now let's look at the 3-liter Vulcan 2-valve engine. It's the same engine used on previous models, with a few new features. Now that the Taurus and Sable are EC5 vehicles, the Vulcan engine uses a PCM-controlled electronic ignition system. The fuel injection supply manifold has been enhanced with a new pressure relief valve and regulator. The PCM relies on input from a new camshaft position sensor. This Hall effect device is used for synchronizing the firing of the sequential fuel injectors. For service, make sure you use the correct new alignment tool for small synchronizers. Connector orientation is critical for proper operation. The 3-liter Vulcan's throttle body is no longer an integral part of the intake manifold. This removable throttle body cannot be cleaned or adjusted. Both exhaust manifolds use new single-layer steel gaskets, which must be discarded and replaced during service, regardless of condition. The right-hand exhaust manifold also includes a new heat shield. Like the 3-liter Duratec, the Vulcan engine uses a closed cooling system with a ratcheting pressure relief cap. Now, let's go on and look at the new powertrain systems that are common to both of these Taurus and Sable engines. 4 heated oxygen sensors are attached to the dual converter Y-pipe. The 2 upstream sensors are for closed-loop operation, and the 2 new downstream sensors are for the OBD2 catalyst monitor function. These sensors are sensitive to rough handling. To avoid damage, always remove them before removing the dual converter Y-pipe and install them after replacing the Y-pipe. The only difference between the exhaust systems is the single muffler on Vulcan-equipped vehicles as opposed to dual mufflers for the Duratec. The fuel tank for 1996 is all new, with the fuel pump module connector accessible without removing the tank. Vulcan-equipped vehicles use a new single-stage fuel pump module, and Duratec-equipped vehicles use a new 2-stage module for increased fuel output. Otherwise, the 2 systems are identical. Position the sender seal in the groove on the tank and snap the 2 retaining clips into the fuel pump retainer located inside the tank. The locking ring must be locked against the stop on the ring of the tank. The PCM relies on a new fuel tank pressure sensor during the OBD2 purge monitor test. This pressure vacuum transducer is also used for fuel system integrity checks to determine if there's a leak in the evaporative system. Refer to the Technician Reference Book for more details about the evaporative emission system. For additional information about OBD2 and evaporative emissions, refer to FCSD's EC5 training and the Powertrain Control and Emissions Diagnosis Service Manual. Now, please stop the tape and answer the review questions for Lesson 1 in your reference book. You can check your answers at the end of the book and review any parts of the lesson you don't completely understand. When you're finished, restart the tape for Lesson 2. The Taurus and Sable transaxles are similar to 1995's. There are, however, a few modifications for AX4N systems. 2 types of transmission range sensor are available. Column shift vehicles use the same 8-pin sensor as previous models. Some floor shift models, however, use a new TR sensor with a 12-pin connector. The additional outputs control a redundant electronic gear display in the instrument cluster. To diagnose the electronic gear display circuits in the 12-pin TR sensor, use the new TR sensor E cable with the Rotunda transmission tester. Attach the connector marked TRE to the tester and attach the analog connector to the TR sensor 12-pin connector. You won't need the digital connector for this procedure. It's reserved for future applications. With the cable switch in the analog position, place the lever in park, then move through all ranges. The LEDs on the cable display should light up for the range selected. If an LED fails to illuminate when the range is selected, it indicates a fault in that circuit from the TR sensor. Another AX4N electronic enhancement is the new transmission control switch for vehicles equipped with the Duratec 4-valve engine. The switch is available on both floor and column shift vehicles and is used to engage and disengage overdrive electronically. The gear display does not include positions for both drive and overdrive. Instead, an instrument cluster lamp illuminates when overdrive is disengaged. Beyond these electronic enhancements, the AX4N is essentially unchanged from 1995. You should, however, be aware of one additional service issue. The factory-installed beveled retaining ring is not notched. Removing this ring may require extra care. Don't score the transaxle case. Discard the ring after removal and replace it with the same size service part. Unlike the factory part, these replacement rings are notched. There are 5 different sizes, and you must inspect the ends of the rings to make the correct selection. Each size has a different end style. Refer to Section 7-1B of the service manual to help you identify the ring you need. Use the retaining ring pliers, which are a new special tool to install this notched ring. Now, please stop the tape to answer the Lesson 2 review questions in your reference book. Again, check your answers at the end of the book and take your time to review any parts of the lesson. When you're finished, restart the tape and we'll begin Lesson 3. The 1996 Taurus and Sable have an enhanced front suspension that's different from 1995. The previous tension struts and lower arms are replaced with one-piece stamped lower control arms. The ball joint is now part of a new aluminum knuckle assembly, and a new special tool is needed to remove the lower control arm from the knuckle. Place the new ball joint remover over the front of the lower control arm and use the Pitman arm puller to separate the arm from the knuckle. The sedan's rear suspension is similar to 1995, but the wagon's has been enhanced for 1996. The tension struts and shock mountings are moved from the lower arms to the new wheel spindles, which have integral ball joints. The system uses new stamped lower control arms, redesigned coil springs, and new one-piece forged upper control arms. On all Taurus and Sable models, the suspension systems are complemented with VAPS-2 variable assist power steering. VAPS-2 provides maximum power steering assist at low speeds and gradually decreases the assist as speed increases. The system is controlled by the generic electronic module, which we'll be referring to as GEM. GEM varies the amount of current to the power steering auxiliary actuator. 1 ampere would be required to fully close this solenoid valve. With the ignition in run or start, GEM monitors the signal from the vehicle speed sensor and varies the output signal to the actuator. For maximum assist below 10 miles per hour or 16 kilometers per hour, the signal is 996 milliamps. The current gradually decreases to 229 milliamps for minimum assist at speeds above 80 miles per hour or 128 kilometers per hour. The Rotunda New Generation Star Scan Tool, or SBDS, can be used to vary the VAPS signals during diagnosis. From the NGS GEM menu, go to Active Command Modes and select VAPS to Output Pulse Control. Now you can vary the signal and use the PIDs to monitor system inputs and outputs. NGS and SBDS are both important tools for diagnosing Taurus and Sable electronic systems. We'll cover diagnostics as well as other functions of GEM in more depth during the final lesson of this program. But for now, Please stop the tape and answer the review questions for Lesson 3 in your reference book. After you've checked your answers and finished reviewing the lesson, restart the tape for Lesson 4. The brake systems for the 1996 Taurus and Sable are similar to 1995. Although parts are not interchangeable, basic brake diagnosis and service are much like previous systems. The anti-lock brake system, however, is all new for 1996. It's a closed anti-lock brake system with no line from the hydraulic control unit to the master cylinder reservoir. Unlike previous systems, the hydraulic circuits are split diagonally. One line supplies pressure to the front left and right rear brakes. The other line supplies pressure to the front right and left rear brakes. Anti-lock operation is controlled by the ABS module, which relies on the four-wheel speed sensors for information about wheel deceleration and wheel slip. The module also relies on the brake light switch. Unlike previous systems, the pedal position switch is not used as an ABS input. The module increases, decreases, or holds brake pressure at each wheel by controlling the solenoid valves in the hydraulic unit. There are 8 valves, 2 for each wheel. Closing a wheel's solenoid valves holds pressure in the line. To release pressure, the module opens the outlet valve. To increase pressure, the module closes the outlet valve and opens the inlet valve. When diagnosing this system, use the new generation star scan tool to control these outputs. From the ABS menu, go to Active Command Modes and select ABS Output Control. Now you can operate the pump motor, open and close the 8 solenoids, and use PIDs to monitor system operation. Likewise, use the NGS anytime you need to bleed the ABS hydraulic control unit. When air has been introduced into the ABS circuits, the bleed procedure requires you to select function tests from the ABS menu and conduct the service bleed function. Continue by following the screen commands for each wheel. The service ABS hydraulic control unit is pre-primed with brake fluid, so replacing it will not necessarily require the NGS procedure. Although the ABS module, hydraulic control unit, and pump motor are integrated as an assembly, each component is serviceable individually. Both the NGS scan tool and SBDS can be used to retrieve diagnostic trouble codes and test the anti-lock brake system. The Taurus and Sable's data link communications make it possible to diagnose 7 different modules, including ABS, through the vehicle's data link connector. We'll cover data link communications and electronic diagnosis in more depth during the final lesson of this program. But for now, please stop the tape and answer the review questions for Lesson 4 in the reference book. We'll look at the climate control system after you restart the tape. The 1996 Taurus and Sable are available with either manual air conditioning or electronic automatic temperature control. Both of these systems use all new controls, which are part of the Integrated Control Panel, or ICP. The clock and the audio system controls are also combined in this one convenient assembly. Beyond the new controls, manual AC operation, diagnosis, and service are similar to last year's Taurus and Sable. The EATC system, however, is somewhat different. The control module, for example, is no longer part of the instrument cluster. Instead, Taurus and Sable have a remote climate control, or RCC module, which is mounted on the evaporator case. To communicate with the Integrated Control Panel, the module uses the Audio Control Protocol, or ACP. It's a data link communication language which is also used by the audio system. Data link communication allows the control panel and the remote climate control module to communicate over a single pair of twisted wires. When there's a communication error between the two modules, the integrated control panel logs a code 7. The display is unaffected and responds to button inputs. But the remote climate control module is unable to respond and defaults to full heat, defrost, and 50% blower speed. We'll look more closely at data link communications in the final lesson of this program and learn how to diagnose ACP network concerns. But for now, you should be aware that the remote climate control module is also part of an entirely different network which uses Ford's Standard Corporate Protocol, or SCP. The SCP network is used to communicate with the powertrain control module, which provides vehicle speed and engine coolant temperature signals. The SCP network is also used for EATC diagnostics. Diagnostic trouble codes are stored in the remote climate control module and can be retrieved by connecting the NGS scan tool, or SBDS, to the vehicle's data link connector. You can also conduct an EATC self-test using the buttons on the integrated control panel. Press the floor and off buttons simultaneously, then press auto within 2 seconds. Any diagnostic trouble codes stored in the remote climate control module appear on the display, and 888 indicates that there are no DTCs stored. Press front defrost to exit and clear the DTCs, or press temp down to exit self-test and maintain the DTCs in memory. Now, please stop the tape once again and answer the review questions for Lesson 5. Check your answers, review the lesson as necessary, then restart the tape for a brief look at the Taurus and Sable's new body features. As we've seen, most every system of the Taurus and Sable has been enhanced for 1996. In this quick lesson, we'll take a look at a few new key body features. First off, a reconfigured switch is used to control the all-new electric outside mirrors. Service no longer requires that you break the glass. Simply remove the heated mirror assembly to access the electric motor. The heating element connectors, however, do not necessarily have to be accessed for diagnosis. Since the system is controlled by GEM, electronic diagnosis is conducted using the NGS scan tool, or SBDS, which you connect to the vehicle's data link connector. The heated mirrors are on the same circuit with the rear defrost relay. We'll look at GEM diagnosis in detail during the next lesson. Among other features, this module now controls the power door locks. The new system includes a lock disable feature to prevent locking keys in the vehicle. When you use the power door lock switch, an open door will not remain locked while the key is in the ignition. Another new body feature is the optional one-touch open electric moonroof. The new overhead module is packaged with the map lamps. A final key body feature to be aware of is the new fold-down rear seats used in sedans. Like previous fold-down seats, there's a release in the passenger compartment. Now, however, the seat can also be released by a second seat latch in the trunk. For the most part, service of the non-electronic body systems is very similar to last year's Taurus and Sable. Always refer to the appropriate service manual section for exact procedures. In the next lesson, we tackle the all-new electronics and diagnostic procedures. But first, please stop the tape and complete the review questions for Lesson 6 in your reference book. Once again, review any portions of the lesson that are still unclear, then restart the tape. The first, most noticeable sign of the Taurus and Sable's all-new electronics is the Integrated Control Panel, or ICP. As we've already seen, controls for the climate control and audio systems, have been combined with the clock in a single assembly. The ICP communicates with other system modules across a single pair of twisted wires using the audio control protocol. ACP, however, is only one of 3 distinct data communication protocols or languages used on this vehicle. The Standard Corporate Protocol, or SCP, is used by a separate network of 3 modules, which also send coded messages over a single pair of twisted wires. A third data communication network uses the ISO 9141 protocol. Unlike the other networks, it uses a single wire, linking 4 modules together for simplified diagnostics. For service technicians, this is crucial. Both the ISO and SCP networks are linked to the vehicle's data link connector. This single connector provides you with access to 7 different vehicle modules for diagnosis with the NGS scan tool, or SBDS. As we saw earlier in this program, the remote climate control and powertrain control modules can communicate over the SCP network. In a few minutes, we'll see how the PCM also communicates with the passive anti-theft module over this same network. And best of all, you can use this data link communication to diagnose all new systems. With the SBDS hooked up to the data link connector, the on-screen prompts guide you through system diagnosis. Using NGS, you can select modules for self-test and several other diagnostic tests. Although the modules on the ISO network don't communicate with each other, they too can be accessed for diagnosis. The ABS module, Integrated Airbag Diagnostic Monitor, Remote Anti-Theft Personality, or RAP module, and the GEM are all linked by ISO to the data link connector. Most modules store continuous diagnostic trouble codes, or DTCs, and allow many other types of diagnostic testing, including on-demand self-test, parameter identifiers, or PIDs, which can be used to verify module status and check inputs and outputs to determine the condition of system operation, and active commands, which allows you to command modules to activate any output to assist in troubleshooting. Unlike ISO and SCP, the audio control protocol cannot be accessed through the data link connector. To diagnose modules on this network, you must use the buttons on the integrated control panel. As we've seen, ACP uses a twisted wire pair for inter-module communication. There's also a third wire, which is not twisted with the others, used to wake up the network modules. These wires connect the integrated control panel with the remote climate control module, which is mounted behind the instrument panel, as well as the remote chassis unit and compact disc jockey. All of this audio processing circuitry is remotely mounted. Like the EATC system, only the control buttons are part of the instrument cluster. Data link communication allows the key components to communicate over a distance. To enter ACP diagnostic mode, press Seek Down and Memory Preset button 3 simultaneously. The display indicates that you are in diagnostic mode and may select from 5 tests. Press Memory Preset 1 for a network self-test. Use the tune control to scroll through the DTCs. 3, 5, 6, and 8 refer to equipment that's not available for Taurus and Sable, so these DTCs should be ignored. Other DTCs indicate network communication failures. As we saw earlier, DTC 7 indicates a failure between the control panel and the remote climate control module. If the vehicle doesn't have EATC, ignore this DTC. Likewise, if the vehicle doesn't have a CD player, ignore a DTC 4. Another test you can conduct from diagnostic mode is the speaker walkaround. Press Memory Preset 2 to activate each of the system's speakers in sequence to test sound. Press 3 for software identification, or 4 to conduct a remote chassis unit self-test. On a base system, 05 indicates that the module passes. On a premium system, 0D is the passcode, and on JBL systems, it's 0F. Press 5 for the final diagnostic test, which lights up the entire control panel display. Remember, these ACP diagnostics do not include self-test for the remote climate control module, which is linked to SCP for diagnostics. Although the self-test can also be conducted using the control panel buttons, the procedure we saw earlier is completely different from ACP diagnostics. Now, let's look at one of the key new electronic components of the Taurus and Sable, the generic electronic module. As we've already seen, GEM combines warning and timing functions throughout the vehicle into a single center of control. Although many GEM features are otherwise identical to previous systems, some are new or different. Familiar features include illuminated entry, the windshield wipers and washer, one-touch-down power windows, the battery saver feature, instrument cluster warning indicators and warning chimes, including the safety belt warning, door ajar, key and ignition, headlamps on, and low engine coolant. As we saw earlier, GEM controls the rear defrost relay circuit, which includes both the heated backlight and the heated outside mirrors. We've also seen how GEM controls the variable assist power steering system. Now let's look at some additional new features provided through GEM. For 45 seconds after the ignition is turned to off or lock, the delayed accessory feature energizes a relay to provide power to the moonroof and window circuits. If a front door is opened during the 45-second period, GEM de-energizes the relay. The battery saver feature protects the vehicle from current drain by de-energizing the interior lamp relay 40 minutes after the key is turned to off. GEM energizes the relay and resets the timeout period in response to a door ajar, door lock, or ignition switch input. Other new GEM features concern the door lock system. In addition to the lock disable feature we saw earlier, GEM allows all doors to be unlocked from the driver's or passenger's door key cylinders. When a key turns to unlock twice within 5 seconds, GEM momentarily energizes the All Doors Unlock relay. Since GEM is part of the ISO network, the NGS and SBDS procedures we saw earlier can be used for diagnostics. GEM supports 9 different active command modes, and PIDs are provided for each input and output. Let's look at an example of a GEM system diagnosis. The customer's concern is that the driver's window will not lower. The other windows, however, operate correctly. Although you may suspect a faulty driver's window switch, you consider that the one-touch-down window system is controlled by GEM. Diagnostic trouble codes can guide you to faulty circuits, and you can use active commands and PIDs to diagnose the system electronically using NGS or SBDS. From the NGS GEM menu, you're able to select the PIDs for the left front window circuit. While operating the suspect switch, you can see that GEM is receiving the switch signals for up and down. You're also able to use PIDs from an active command screen. From the one-touch down command, you select the same PIDs and observe them while controlling outputs. You can activate both the delayed accessory and one-touch down relays. Using these features, you can confirm that GEM is receiving inputs and that it's sending output signals. Although you first suspected a faulty switch, you can now see that the concern is on the output side of the circuit. Use the symptom charts and pinpoint tests in the service manual to diagnose GEM circuits using NGS or SBDS. Another diagnostic improvement for Taurus and Sable is the new Integrated Airbag Diagnostic Monitor, which includes an integrated safing sensor and backup power supply. Although airbag system operation is similar to previous systems, diagnostics are not. The monitor is linked to the ISO network, so you can use NGS or SBDS to retrieve and clear DTCs through the data link connector. No connectors need to be jumped or grounded manually. The airbag monitor also supports one active command, which allows you to test the operation of the airbag warning lamp and chime. The 1996 Taurus and Sable include two completely independent anti-theft systems. The two systems share an indicator in the cluster, but don't directly work together. The perimeter anti-theft system is controlled by the Remote Anti-Theft Personality, or RAP module. As we've seen, the RAP module is part of the ISO network for NGS or SBDS diagnostics. Perimeter anti-theft operation is similar to previous systems. There are 4 ways to pre-arm the system. You may press the power door lock and close the door. Press lock on the key fob. Press the last 2 keypad buttons simultaneously, or turn the key to the lock position twice. 30 seconds after any of these events, the system is armed. To disarm the system, press unlock on the key fob, unlock the door using the keypad, unlock the door with the door key, or turn the ignition to run accessory. To program additional fobs into the RAP module, make sure the anti-theft system is not armed. Then, turn the ignition from off to run accessory 5 times within 10 seconds. If successful, the RAP module enters program mode and locks, then unlocks all doors. Press any button on a new fob and the doors lock, then unlock. You can also enter additional fobs at this point. When finished, turn the ignition to off. The doors will lock, then unlock to indicate that the new key fobs have been programmed to the RAP module and that the module has exited program mode. The Passive Anti-Theft System, or PATS, is an entirely new system controlled by the PATS module, which stores ignition key codes in non-volatile memory. The system prevents the engine from starting unless the correct ignition key is used. PATS keys are larger than ordinary keys due to an electronic chip which transmits an identification code when turned to run or start. A transceiver below the ignition cylinder receives the signal and sends it to the PATS module. Since the PATS module is part of the SCP communication network, it's able to communicate with the PCM. At each engine start sequence, the PCM allows fuel and spark until the engine runs. Within 1 second, however, it must receive an enable signal from the PATS module. If the PATS module hasn't received a valid key signal, the PCM disables the engine for 15 minutes. The PATS module can recognize up to 16 keys. To program additional keys, turn the ignition from on to off with a previously programmed key. Within 15 seconds, insert a new key and turn to on or start. If the programming is successful, the theft lamp on the cluster lights up for 2 seconds. If all programmed keys for a vehicle are lost, use NGS or SBDS to reprogram the system. Using NGS, select the command from the PATS module Active Commands menu. Follow the screen commands to erase codes for the lost keys and insert a newly cut PATS key to be programmed into the module. You'll have to wait 8 minutes before the module accepts the new key code. NGS informs you when the test is successful. Use the new key to program any additional keys to the module. As you can see, the new Taurus and Sable electronics are a giant leap forward. Data link communications provide for many new and simplified features, as well as simplified diagnostics. Using NGS and SBDS allows service technicians to contribute to the customer satisfaction that has become a Taurus and Sable tradition.